Expectation. So what is an expectation? What do you mean by expectation? So let me write down expectation. So let's understand expectation with the help of an example. Say for example, if you consider European people, or if you go to Europe, what do you expect their heights to be? Greater than Indians people, right? So in general, Europeans are taller than Indians. That's what we expect them to be. Okay, so that's the general notion. On an average, a European is taller than Indian. So when we say that we expect something to be, or the expectation is that Europeans are taller than Indians, so by this statement we mean that on an average, are all Europeans taller than every Indians? That's not the case, right? So expectations means when I say that I expect something to be a certain way, we mean that on an average, and that's what expectation means, on an average or central tendency. Okay, so let me define it for you. So expectation, as I mentioned, that this is the central tendency of any data. What do we mean? I'll give you some more definitions, some more one-liners around that. So if we do a random experiment several number of times, then whatever values we get, and if we take the average of that value, that is the expected value of the random variable. Similarly, we can say that a long run average. So I can say that this is the long run. It's the same thing. Doing an experiment multiple times, and okay, you perform an experiment multiple times, and then whatever values you get, you take an average of that. That's what is the expected value. Generally, that's the average or mean. That's what expectation means. I hope the intuition is clear about expectation. If this is clear, right, then rest of the things will follow. So this is the main agenda, to understand what does the expectation. This is a literal meaning, okay, that we bring that concept in probability and statistics, and we use that term. So if I give you one more analogy, it's similar to the center of mass in physics. Okay, it's similar to center of mass. Center of mass. This is where you expect the most of the mass to be. The central point of any object. So this is what your expectation means. I hope expectation is clear. So let's define it formally. What does expectation mean? Okay, and again it will be as I mentioned, these all terms are for random variables. So random variables are of two types. We have discussed that earlier: discrete and continuous. So first is for the discrete case. If for a discrete case, discrete random variable, what would be my expectation? Expectation generally it's given by E of x, and this is given by summation over I, all the sum. Okay, you have the value, whatever is the value x of I, into probability of that value. So this is kind of a weighted average. Because each value can have a different probability. If all the numbers are having the same probability, then it will give you the simple average. But if each value has a different probability to occur, then this will give you a weighted average. So this is in the case of discrete. Let me give you an example, simple example, so that you understand. So I'll give you a question. Say for example, we are playing a game. Okay, so in that we toss a coin, and if we get a head, okay, if you get a head, then you win rupees 100, and if you get a tail, then you lose rupees 50. Okay, plus 100 on heads, minus 50 on tails. So if we play this game for a long time, okay, we do heads, tails multiple number times. So what is the expected amount that you will win after several times you have played this game over a long run? So let's compute that. That's what will give you the intuition of this. So let me write the question for you. So the question, let's play a game. So the question is, let's play a game. Let's play a game where we toss a fair coin. Okay. if it's head, then you win ₹100, and if it's tails, then you lose ₹50. And it's a fair coin, so probability of head equal to probability of tail is equal to half. Okay, so what's the question? What is the expected amount that you will win in long run per toss? So that's the per toss value, because per toss you are getting 150. So what is the average amount, okay, per toss? Expected amount means per toss how much you will win on an average. Okay, so that's the expectation, means on an average. You have understood that. Let's solve it. Very simple. So the solution would be, so how do we solve it? So we know that probability of head is equal to probability of tail is equal to 0.5. This is the first thing, because it's a fair coin. And then what else? So what are the possible outcomes? You have to do a summation possible outcomes. Say for example, we have x1 equal to plus 100 and x2 is equal to minus 50. Let's write it like this. Okay, probabilities we have of both of them is half, so that's not a problem. So our expectation E of x is defined as summation over I xi into probability of x is equal to x of I. So if you see the notation, generally for discrete we use the probability, and in analogous we use the function x, right? So I'll just keep on reinforcing this concept, that for, because in probability we have the in discrete values, for discrete values we have the probability of each and every discrete point. So that's why we mentioned the probability at x is equal to xi, but that's not the case in the continuous, for continuous random variables. So that's why there we denote the same thing as function of x, small fx. Okay, this is how we write. We'll come there again, but I just wanted to make this point clear, because this is very common terminology that it should be very clear in your head. So what will be, this is the expectation, probabilities we know. So what are the values we have? So we have x1 into probability of x is equal to x1 plus, open it up, x2 into probability of x is equal to x2. So x1 is 100 into 0.5 plus, what is x2? That is minus 50 into 0.5. Simple, 50 plus minus 50 into this, that is minus 25. That is equal to 25. So this is the amount, expected amount you will win. Expected amount you will win per toss is equal to ₹25. That is after you have played the game for a long time. So you should expect to win ₹25. Good deal. Okay, I hope the discrete case is clear. Now let's move to the continuous case. Very simple. So just get the definitions right and you're done. So second is continuous case. So how did we write it? First is discrete. So let me write the second one. Continuous random variable. So in the case of continuous random variable, as I mentioned, we use small fx. Okay, so what would be the expectation here? This is defined here as, we do an integration from on the complete sample space minus infinity to plus infinity, and then x into function of x dx. So this is your PDF. And what do we call this generally? This is your PMF, probability mass function, which gives the probability at a particular value. And this function of x, this is, okay, this is your f. Okay, let me write it small f. Small f. This will give you the probability function, which will give you the value of that function over, if this is the graph, this will give you a value over a range, okay, over an interval what is the value, and we integrate this. Okay, when we get into calculus, I'll discuss more about integrals and differentials, so don't worry, I'll put all the links in the description. This is a definition. Okay, so let's solve a simple problem to understand what is on the continuous side also. So we have seen uniform random variable, for example. So let's find the expected value. So let's write it as a question itself. So let's do a known problem. Find the expected value. When we say expected value, means mean, mu, of uniform distribution, uniform continuous distribution. We know that what is the value, we have seen that earlier. So what is the value we should get? So what is the mean? Is equal to b plus a by 2. We know this. Now let's derive this. What is the PDF of uniform variable? How is it defined? 1 by b minus a for a is less than equal to x is less than equal to b and 0 otherwise. Do you remember the graph? How is it? So let me plot the graph for you. This is the graph, right? If this is a, this is b, what was this value? 1 by b minus a. Remember, this length is b minus a, and this whole area is equal to 1, because this gives us the complete probability, and probability, the complete probability of anything is 1. So this area under curve always gives us the complete probability, that is 1. So this value is 1. If this is b minus a, this should be 1 minus b minus a, because this is a rectangle. Length into breadth is equal to 1. Okay, from this will be 1 by b minus 1. I hope that's clear. So this is your function. So we have the PDF. We know this should do the mean. We'll derive this now, and we know what is the expected value. So let's do the maths. So let's derive derivation. So expectation of x is equal to integral minus infinity to infinity x into f of x dx. Let's plug in the values. This is integral. What is x will be as it is. What is function of x? This is 1 by b minus a dx, because this is the expected value throughout the region. This is the mean, right? This is the expected value throughout. This is uniform. That was, remember, the random number generator. Whatever number you choose, it will have the same probability. Here I hope you remember this will give you the value of x, and here you will get the probability. This on y-axis, this is 0. So the probability of all the numbers in this range, occurrence of all these numbers, is equally likely. So that's why we have a constant straight line. So this is our probability. Now let's integrate this quickly. So let's break it down into 3 parts. One is, sorry, remove this, minus infinity to a x into 1 by b minus a dx plus a to b x into 1 minus b by a dx plus b to infinity x into 1 by b minus a dx. We know that our function is defined only for this range, that is a to b. For the remaining, it is 0 otherwise. So this will become 0. This is 0. This is 0. So only this remains. So this function will be defined as integral a to b. Let's bring this 1 by b minus a is a constant with respect to x, right? We are not integrating. X of dx. What is this value? That is 1 by b minus a into, what is the integral of x? x square by 2, sorry, from a to b. This is the value. Increase the power plus 1 and divide the same thing and the denominator. That's how integration works. So this is equal to 1 by 2. I bring this 2 out, that is a constant, and then let's put the upper and lower limits into b square minus a square. Upper limit minus lower limit. That is 1 by 2 b minus a. Can we write b square minus a square as b plus a into b minus a? Now b minus a cancels out. What remains? This is equal to b plus a by 2. So this is your expected value of a uniform distribution, and that's what we know already. So hence proved. So I hope the continuous the expectation for a discrete and continuous random variable is clear, and expectation in general is clear. Now let's use this concept to derive the formula similarly for variance and covariance next. Okay, so let's do it for variance. So I'll do a quick overview of variance. We'll dive deeper into variance and covariance and its other statistical properties when we go to statistics. But till now you must have got a fair idea what is variance. I've discussed this earlier too. So what is variance? What does it tell me? Variance gives me the spread of data, how spread out the data is, right? It gives me the spread of data. Spread means how it is positioned around the mean, whether it is very close to mean or it is all the data is scattered away from mean or it's all over the place. Spread of data or variability, how much variation is there. This is what it means. That's the understanding, and by definition it is the square of the distance from the mean of all the values. You sum it up. Okay, measure it as sum of square of distance from mean, right? Square of distance from mean. This is the theoretical definition. Okay, so if the variance is low means all the data is close to the mean, and if the variance is high means the data is very spread out and it is away from the mean. Okay, now let's use this so for our calculation. So we know that mean, we know that expectation is our mean. This is equal to average. So we know this already. So what will be the variance? How is the variance defined? So let's take it from the definition. Variance is, now I want to find the expected value of distance of all the points from the mean squared. So this is the distance of each and every point, x from the mean. This is your mean, and the square of that, and I have a series of values. So what is the expected value now? Okay, what is the expected value? Let's solve this and get the formula out of it. So expectation of, spread the inner term, a minus b whole square, a square plus b square minus 2 a b. Okay, let's open the expectation of x square plus, okay, expectation of x square would be expectation of x whole square. That is my mean. This is a constant value. Expectation of any value is a constant value. That is my mean. I know that. And expectation of a constant value, expectation of 1 or 2 will be 1 only. Nothing changes there, right? So this is a constant value, and expectation of a constant value will be the value itself. So expectation of this would be this value itself. So this will be expectation of x whole square itself. Nothing changes. Expectation of a constant is a constant. So expectation of x whole square will be expectation of x whole square itself. Expectation of 1 is 1, expectation of 10 is 10, because it's constant, nothing is changing there. I hope that's clear. Minus expectation of x, this value x is 2 into expectation of x into expectation of x. So this is equal to expectation of x square plus expectation of x whole square. This is minus, these two terms are same. This is minus 2 times expectation of x whole square, because expectation of x both are same. What will this become finally? This will become expectation of x square. These two are this expectation of x square 1 time minus expectation of x square 2 times will become minus of expectation of x whole square. This is nothing but your variance. This is how it is defined. Variance of x is expectation of x square minus expectation of x whole square. So expectation of the second degree term and the expectation of first degree terms whole square. This will give me the variance. I hope the variance is clear. Now let's use this understanding again. So why is this important? Why are we studying this? So this is important because this formula is generally used for computation. I'll write a note. This is the computation formula for variance. Because expectation of x, finding this is very easy, because now when we read the moment generating function next, right? So finding these values are very easy computationally. Instead of going through the formula that you go through each and every value and find that, instead of this, finding these values are simpler. So for computational purposes, we use this expectation formula, and that's why it is important. Okay, I hope that is clear. So now let's understand this using another example. So for example, we'll continue the example of uniform distribution, and we'll find out the variance of uniform distribution using this variance formula, using this variance and expectation formula. So let's find out the variance of uniform distribution. Question is, find variance of uniform distribution. What is the variance of uniform distribution? We know that from past. Variance is given by b minus a whole square by 12. And you have seen what is the uniform distribution. This is our uniform distribution, which is defined over f of x is 1 by b minus a for in the range a to b. This is the uniform distribution. And the variance of that is given by b minus a whole square by 12. We have seen this in the previous video. So let me write down the PDF again. PDF is equal to f of x is equal to 1 by b minus a when a is less than equal to x is less than equal to b, and it's equal to 0 otherwise. This is our f of x, the PDF. So we know that expectation of x is equal to b plus a by 2, and we know that variance of x is equal to expectation of x square minus expectation of x whole square. So this term is available. Now we need to find this term, right? This term we have. Now we want to find this term, and then we'll plug it. So let me give values to this. So this is 1, this is 2, and now let's find task. Find expectation of x square. You know what is the formula for expectation of x is equal to integral minus infinity to infinity x into f of x dx. Similarly, what will be the expectation of x square? What will be the expectation of x square? Simple, plug, replace this x with x square. Minus infinity to infinity x square into f of x dx. Let's plug the values now. We know that this is defined over a to b, so this will become 1 by b minus a. I'll go fast now. A to b, and this will be this is f of x was 1 by b minus a. I brought it outside. What remains inside? X square dx. This is equal to 1 by b minus a. A to b. What is integral? Integral x square dx. Again, increase the power by 1 and divide by the same number. This is for the range a to b. This is equal to, let's bring this out, 1 by 3 times b minus a into upper limit minus lower limit. So this is, we know what is the formula for b cube minus a cube from our high school. B minus a into a square plus b square plus ab, 3 times b minus a. This b minus a gets cancelled, or this is equal to a square plus b square plus ab by 3. This is your expectation of x square. So let's say this is our equation number 3. Now we have expectation of x square. That's what we needed. We have this variance formula where we need x square, expectation of x square, expectation of x. We have expectation of x. Let's use all these values to find the variance of x now for uniform distribution. So what will be the variance of x? So variance of x is equal to expectation of x square minus expectation of x whole square. This is equal to a square plus b square plus ab by 3 minus, sorry, this was b plus a, b plus a by 2 whole square. This is equal to, I'll go very slow with the maths, b plus a whole square, high school again, a square plus b square plus 2ab by 4. LCM of 3 and 4, 12. Multiply this 3 times, this 4 times, and subtract. So what will be 4a square plus 4b square, sorry, I'll remove this, 4a square plus 4b square plus 4ab. I multiplied this here. Now 3 times this value, subtract it because you know the maths. This is minus 3a square minus 3b square minus 6ab. I open the brackets. What remains? 4a square minus 3a square, a square, 4b square minus 3b square plus b square plus 4ab minus 6ab minus 2ab by 12. Is it not a minus b whole square formula? We can do reverse also. It's the same thing. A minus b or b minus a, square is positive, always positive. So this is your variance of x. So again, I'll write it as variance of x for uniform is b minus a whole square by 12. And we know this, that is the formula, hence proved. Okay, I hope variance is clear. Now let's move to the next topic, covariance. What is covariance? When we say co means, again, two things changing together. Co means always there are two things. So what does covariance mean? This measures how two variables change together, okay, or vary together. Measures how two variables, random variables, x comma y, vary or change together. This is what covariance means. So the values generally, so the values are, if it is given by covariance of x comma y, if it is, it will be either greater than 0, less than 0, or equal to 0. If it is greater than 0 means it's positive, means both x and y are positively means they vary positively, means if x increases, then y also increases. Okay, if it is greater than 0, if it is less than 0, if x increases, then y decreases. That is negative covariance. If one increases, other decreases. Positive means both grow together or both come down together. If x comes down, y comes down. If x goes up, y goes up. That is positive covariance. Positive covariance. Negative covariance, inverse relation. X goes up, y goes down. Okay, x goes down, y goes up. That is negative. I hope that's clear. And 0 means nothing. No covariance. Both are independent. Okay, no linear relationship. No linear relationship, no relationship between x and y, and vice versa. Whatever. Okay, so I hope covariance is clear. So we can use the again the same formula. Let's find out how do we calculate covariance. So you will use expectation to find covariance now. So covariance of x comma y is equal to, how is it? It is the expected value of x minus expected value of x into y minus expected value of y. Generally this is your called mu x, this is the mu y, that is the mean, and now we have replaced that with the expected value. Okay, and why are we are studying expected value of anything? Because it is computationally easier to compute. It's easier than going through the formula path. So what's the covariance again? So let's expand the internal part first. X into y, xy minus expectation of x into y minus expectation of x into y, then x into minus, so it should be minus x into expectation of y minus plus expectation of x into expectation of y. This is the whole thing. This is equal to, now let's expand this. So open this bracket up. So expectation of xy will be expectation of xy minus expectation of, as I mentioned, expectation of x. This is a constant value. So expectation of a constant value is the constant value itself. So nothing changes here. So this is expectation of x into expectation of y minus again expectation of x into expectation of ey is a constant value, so this is a constant value, expectation of y, and then the last term is plus expectation of x into expectation of y. Let me bring it this side, very squeezed up. Okay, expectation of x into expectation of y. So if you see, this term and this term are same, this gets cancelled, and then finally this is equal to expectation of xy minus expectation of x into expectation of y. This is your covariance x comma y. I hope covariance is clear. So there's one more important thing just to know, good to know, that is for the future. So we will come across this covariance matrix a lot, covariance a lot, especially when we do singular value like decomposition, etc., and multiple other places also wherever we have multivariate. Okay, so in the multivariate context, so we will have this. So relationship between all the random variables will be captured via, so this gives relationship, right? Covariance relationship between all pairs of random variable, I'll write RV, are summarized in a, because both the numbers will be same, n random variables. So relationship between all of them would give me n into n matrix in a square, that is called square. We'll discuss about this in the vectors or in the linear algebra module, and it will be symmetric also, because relationship between x and y is same as relationship between y and x, nothing changes. Square symmetric matrix. This is called covariance matrix. Covariance matrix. This is often denoted by this sigma, this symbol, and all the diagonal elements of those will be like covariance of x with respect to x, or anything covariance of y with respect to y. What will that be? So all the diagonal elements where it is the covariance of a random variable with itself, diagonal elements will be the variance. Okay, how? Let's quickly do the math. So if someone who doesn't get it, so let me do the math. So what we know, covariance of x comma y is equal to, we have seen this, this is expectation of xy minus expectation of x into expectation of y. So what will be covariance of x comma x? Should be equal to xy will be x square and minus e to the power x into e to the power x, means expectation of x whole square. What is this? This is equal to variance of x. I hope this is clear. Okay, so that's what was covariance with respect to expectation.